Hello everyone, in my previous video we successfully built a production grade data engineering pipeline that ingested raw data, processed it using Apache Spark on EMR and exposed it via Athena for analytical discovery. Today we are showcasing the extension of POC1. We are moving from purely analytical querying to a high performance operational serving layer. As you can see on the diagram, we are integrating AWS Glue, PySpark ETL, and Amazon Aurora PostgreSQL Server. This architecture is designed to power real-time downstream applications, microservices API, and operational dashboards with sub-millisecond query performance. A key architectural decision in this pipeline is transition from Amazon EMR to AWS Glue. In phase 1, we leveraged EMR because it gave us full cluster management control and distributed computing power over EC2 to handle raw, unorganized clickstream logs. It was the ideal choice for heavy-duty data cleaning and transforming raw data into highly optimized Parquet files. However, for this operational phase, we transitioned to AWS Glue because Glue is entirely serverless. We don't have to manage any infrastructure. It integrates natively with our existing Glue data catalog schema and provides built-in secure JDBC connectivity. This makes it perfect micro-batch connector to dynamically stream our refined data into our transactional serving layer without the overhead of spinning up an entire EMR cluster. Okay, let's move to our AWS console. Um, these are our input partitions which were generated by EMR cluster in our previous video. Now I'm going back to Amazon Aurora PostgreSQL. So I'm just logging in using Cloud Shell. Okay, I have logged in here. Um, we'll just query a table. Like I have created this table previously and now I have dropped it. To prove this as a live session, I wanted to make this sure. So this table doesn't exist. Now I will create this table. Okay. So I'm creating a table here. I'm creating a table here. This table has been created. Now I am querying it and we don't have any record here, right? So in our previous video, we saw this Amazon Athena, right? So here I have made a CTE from our table, from our clickstream analytics table, which is nothing but S3 bucket folder, right? So here I have made some transformations and I have generated category, total clicks, total sales, gross revenue, and as well as conversion rate. Along with that, we are taking the current timestamp as well. This is a CTE. So I'm running this query here. So I got this output here, but I wanted this output in my Aurora PostgreSQL. Now moving Spark executors into a private relational database layer introduces a significant cloud networking hurdle, VPC Network Isolation. The moment our Glue job connects to the private database subnet, it loses public routes to the S3 data lake. To overcome this securely and cost effectively, we have provisioned an S3 Gateway VPC Endpoint. This creates a private isolated network highway within the AWS backbone, allowing our Glue Spark engine to stream data out of S3 securely without traversing the public internet. Now going back to our Glue Studio, okay, AWS Glue Studio. Here I have my entire ETL script. So I'm just importing required modules and libraries. Then I'm just connecting to the AWS catalog and I mean Glue catalog, and then we are taking the metadata, and we are taking we are querying our data in S3, like the same query whichever we saw in our Amazon Athena, right? So the same query we are querying, and we are storing it as a data frame using Spark SQL. We are querying it and we are storing it as a data frame here. Then this data frame is moved to Aurora Postgres. So this particular job takes the data from S3 parquet files through this query, and it will load into our Postgres table, which is e-commerce performance summary here, right? Okay. Now let's run this job. So I'm going to run the job. So the job is running now. So the job is completed by 2 minutes and 10 seconds. Now let's go back to our PostgreSQL, and I'm just querying the same table. See the exact result. Whatever we got in our Athena, we are getting the exact result in our PostgreSQL, right? Aurora PostgreSQL. So our AWS Glue job uh, takes the data from gold zone of S3, and it uh, uh, uses our CTE, and it puts the data inside this Aurora Postgres. So this successfully demonstrates how a serverless data lakehouse seamlessly bridges big data storage with transactional serving capability. These records are now fully ready to back any enterprise API or live dashboard. Thank you.